Today we are learning about the properties of addition and multiplication. So what are properties? Math properties are rules in math. Properties are always true for every number. First, we'll talk about the commutative property. So what does the word commute mean? To commute means to travel from one place to another. For example, you commute every day to school in the morning. So just like you commute from home to school, a number may commute from one spot to another. If we're looking at the commutative property of addition, you notice down below a plus b equals b plus a. All that happens is the numbers change places. This is called the commutative property of addition. Another example with numbers is 2 plus 3 equals 3 plus 2. Again, all that happened from the left side of the equation to the right side of the equation was that the 2 and the 3 switched places. So both 2 plus 3 and 3 plus 2 equal 5. The commutative property can also be seen with multiplication. So in the same way, all the numbers are going to do are change places. So you see down below, a times b is equal to b times a. Or an example with numbers, 3 times 5 is equal to 5 times 3. All those numbers did was switch places. Both 3 times 5 and 5 times 3 equal 15. This is called the commutative property of multiplication. Now let's talk about the associative property. So what does the word associate mean? An associate is a friend or someone you work with. For example, the head cheerleader is an associate of the school mascot. Now imagine the football team played a late game and the cheerleader and mascot both forgot to study for the math test. So the cheerleader might choose to associate with someone else to help her study for the math test. So the associative property is when a number associates with a different number. I have an example with addition and multiplication. So in both scenarios, we're either adding a, b, and c, or we are multiplying a, b, and c, all representative of numbers. In the adding example, first we have a plus b that are associating together inside of parentheses, and then we're adding c outside of the parentheses. The c is not associating with the a plus b. But then down below, now b and c are associating with each other inside the parentheses, and a is not associating with either b or c. A plus b plus c. In the multiplication example, we are multiplying a, b, and c together. At first we see a times b associating with each other inside of the parentheses, and then we're multiplying c outside of those parentheses, so it is not associating with a or b. Then down below that, it's the same multiplication problem, but now B and C are associating with each other, and A is not associating with either of the two numbers. So the numbers are choosing to associate with different numbers. So when looking at the associative property of addition, what we just looked at before, I've put into an equation form with left and right. So on the left-hand side of the equation, the A and the B are associating together, and on the right-hand side of the equation, the B and the C are associating together. This is called the associative property of addition, when numbers choose to associate with other numbers. So an example with numbers is 2 plus 3 plus 4. The 2 and the 3 are associating together inside of parentheses, equals 2 plus 3 plus 4. But this time, the 3 and the 4 are associating together. The important thing to remember is the order in which you add does not change your answer. So it doesn't matter which numbers are associating with each other, you're going to get to the same answer. The associative property of multiplication is very similar. So we saw this example a couple of slides ago. A times B times C. The B and the C are associating with each other on the left-hand side of the equation. But then on the right-hand side, after the equal sign, the numbers have switched associations. So the A times B is associating together now, and C is not associating with those other two numbers. This is called the associative property of multiplication. So an example with actual numbers is 2 times 3 times 4, and the 2 times 3 are associating together, equals 2 times 3 times 4, the same numbers, but this time the 3 and the 4 are associating together. As with addition, the order in which you multiply does not change your answer. Next, let's look at the identity property. So what does the word identity mean? Your identity is who you are. Changing your clothes or getting a new haircut does not change your identity. Your identity will remain the same. So looking at the identity property of addition, a number also has an identity. The identity of a number is the value of the number. The additive identity is the number that when added to another number does not change the identity of the original number. So in order not to change the identity of the original number, there is only one number that we can add to that number so it will remain the same. That number is 0. So when we add 3 plus 0, it equals 3. So the identity of 3 did not change, it remains the same. If we had the number 8 and we wanted to add a number, but we did not want to change the identity of 8, the only number we can add to it is 0. With the identity property of multiplication, the multiplicative identity is the number that when multiplied to another number does not change the identity of the original number. So with multiplication, if we do not want to change the identity of our original number, there's only one number that we can choose to multiply that number by, and that number is 1. So if we have the number 3, and we need to multiply 3 by a number, but we want the identity of 3 to remain the same, the only number that will accomplish that is the number 1. So 3 times 1 equals 3, and we've kept the identity of our original number 3. Another example down below, if we have the number 9 and we want to multiply it by a number, but we want to keep the identity of the original number 9, the only number we can choose is to multiply it by 1. So this is the identity property of multiplication. Last, we're going to look at the distributive property. So what does the word distribute mean? To distribute means to share evenly. So if you and 3 friends were to split an 8-slice pizza, that's 4 of you, so each person would get 2 slices. You are going to distribute those slices evenly. So in the example down below, you see 2 and then 1 plus 3 in parentheses. Notice how there isn't an operation sign between the 2 and the parenthesis. Anytime you don't see an operation sign, it's going to be multiplication. So we need to multiply 2 by the numbers in the parentheses. So 2 will represent our pizza slices per person. The 1 inside of the parentheses represents you, and the 3 inside of the parentheses represents your 3 friends. So if we want to distribute 2 slices to each person for this 8-slice pizza, we need to multiply 2 by each of the numbers inside of the parentheses. So we're going to multiply 2 times 1, and then 2 times 3 for your 3 friends. Notice how we keep the plus sign in between. The distributive property multiplies or distributes the outer term to the terms inside the parentheses. After you have distributed, you can combine like terms. So in our same example from the last slide of splitting the pizza slices, when we multiplied the 2 times the 1 and the 2 times the 3, those are like terms, so we can go ahead and solve for that. So 2 times 1 is 2. We're keeping that plus sign in the middle. And 2 times 3 is 6. And if we were to add 2 and 6 together, we would realize that that equals 8. And that represents our 8 pizza slices. So looking at your notes for today, we are going to fill in a few blanks together, reviewing these properties. So the first property is the associative property. So when we're looking at the associative property, the numbers are choosing to associate with different numbers. But when adding or multiplying the numbers, the grouping does not matter. So there's a couple examples down below, and you'll see how on the left-hand side of the equation, the 7 and the 3 are associating together. And on the right-hand side of the equation, the 3 and the 4 are associating together. But when you add all those numbers up together, it doesn't matter which ones are associating, you're going to get to the same answer. The multiplication example down below that, you see the 9 and the 5 are associating together on the left-hand side of the equation, and then the 5 and the 8 are associating together on the right-hand side of the equation. But again, the grouping does not matter. Then the commutative property, when adding or multiplying two numbers, the order does not matter. So the numbers are going to commute or move around from one place to another, but we're still adding the same numbers or multiplying the same numbers on each side of the equation, so we're still going to get to the same answer on both sides. So we have an example with multiplication and addition down below, and you'll notice that the numbers are in different places, but on both sides of the equation, we're either adding or multiplying the same exact numbers. Then with the distributive property, the number on the outside of the parentheses gets multiplied by the numbers on the inside of the parentheses. So we're distributing, or we're evenly sharing that number on the outside to the numbers on the inside. Then with the identity property, for addition, the sum of any number and 0 is that number. So we'll always add 0. And for multiplication, the product of any number and 1 is that number. So we'll always multiply by 1. There's also another property that we haven't talked about yet called the inverse property. For addition, the sum of any number and its opposite will equal 0. So there's an example down below. 9 plus its opposite, -9, equals 0. The inverse property of multiplication, the product of any number and its reciprocal is 1, or it equals 1. So in the example down below, you have two wholes. If we pretended that the 2 was a fraction, we would have to put the 2 over 1. And then to find the reciprocal, all we would do is flip those two numbers around. So the reciprocal of two wholes is 1/2. And when we multiply those together, it equals 1. Now we will complete some guided practice problems together.